The modern thermometer was invented in the 1700s, but it took more than a century for them to be reliably accurate.
So how can today's scientists measure temperatures that go back hundreds or thousands of years? 3 words: ice core samples. They contain bubbles of air that, when they're analyzed, can show a record of temperatures that in fact go back hundreds of thousands of years.
It's those samples and the data they provide that Keith Carson looks at in this week's report on Maine's changing climate.
We know via temperature proxies such as ice cores, snow, fossilized corals, and lake sediment that although the Earth has warmed and cooled in the past, it's never done so at such a rapid rate. According to NASA, our current warming is occurring 10 times faster than the average rate of warming after an ice age. But would the Earth be in a warming phase if it weren't for anthropogenic influences, aka human activity such as burning fossil fuels? To get to the root of this question, we need to understand something known as radiative forcing. Radiative forcing is the change in energy flux in the atmosphere caused by natural and man-made factors. The balance of radiative forcing determines whether the Earth is cooling or warming. Since the atmosphere is complex, there are several factors that impact the radiative forcing budget. The most obvious is the sun. Although the sun provides almost all the energy to the Earth via incoming solar radiation, it doesn't tend to vary much on small timescales such as hundreds or thousands of years. There are several satellites that measure the incoming radiation from the sun, and when paired with historical reconstructions via Sunspot data, the graph shows a stable trend going back to at least the 1880s, which is the beginning of the Industrial Revolution. And remember, we're looking to explain rapid warming in relatively recent years, so the sun's out. Digging further into the forcing, you'll see ozone broken into 2 colors in the same bar on our chart. A slight depletion in the stratospheric ozone, which has greatly improved since banning CFCs in the mid-1980s, has had a net cooling effect, while tropospheric ozone is the primary ingredient in smog and acts as a greenhouse gas, trapping heat. The biggest cooling effect you'll see on the man-made side is aerosol-cloud interaction. As particulate and pollution are put into the atmosphere by humans, it can act as cloud nuclei, increasing cloud albedo, which reflects more shortwave radiation back into space and allows less solar energy to the surface. You can see even seemingly small forcing mechanisms are taken into account, such as black carbon on snow. That's when soot from pollution accumulates on snow and ice. This darker color causes the albedo of the snow to change, which causes it to melt faster, which exposes more Earth, which has an even higher albedo and absorbs more sunlight. When scientists look at all these forcing mechanisms, they reach the conclusion that without man-made influences, the Earth would be in a nearly stable temperature regime since the Industrial Revolution. Instead, we're warming faster than any other period in history. One last thought. The time scale here is key. We've had ice ages and we've come out of them long before man put a carbon footprint into the atmosphere. But those changes occurred over tens of thousands to hundreds of thousands of years via known mechanisms like Milankovitch cycles. These cycles include variations in the shape of Earth's orbit, the angle Earth's axis is tilted with respect to Earth's orbital plane, and the direction Earth's axis of rotation is pointed. These cycles cannot and do not explain our rapid warming over the past 100 years. Keith Carson, News Center, Maine.